And we're live.
Thanks, Peter. Thank you for all of you for joining us today at Istio Weekly. We'll be talking about multiple Istio ingress gateways, and Peter will take you through the details of setting that up. We'll have dedicated time for Q&A after the presentation, but we'd love to have this be a conversation as much as possible given the format. So if you have any questions or comments, please put them in the chat, and we'll do our best to moderate as it makes sense. Before diving into today's topic, let's take a moment to cover some recent highlights and upcoming events of note. Istio 1.10 dropped in May with some performance improvements, including discovery selectors. Previously, Istio's discovery mechanism watched and processed updates for all Kubernetes resources, which could lead to bottlenecks. Discovery selectors now let you limit the scope of Istio's discovery to a specific set of namespaces. Also new in Istio 1.10 is the introduction of revision tags for smoother canary updates. Revision tags are stable identifiers that point to revisions and can be used to avoid the donkey work of relabeling namespaces. This addresses one of the major usability complaints about revisions, that a lot of namespace labeling was required to change revisions because a label mapped directly to a specific Istio control plane deployment. Here at Tetrate, we just published a new blog introducing Tetrate Service Bridge with a demo by our own Adam Zwicky. He does an excellent job of running TSB through its paces and showing off some of its core capabilities. If you're interested in learning more about TSB, that's a great place to start. And also Tetrate founder and CEO Varun Talwar was a recent guest on the Tech Talks Daily podcast, where he talks about when to use service mesh, app modernization, TSB, and more. And so see if you can guess what Varun's first computer was.
Was it an Amiga or a Commodore 64?
You'll have to listen to the podcast.
All right.
So Jimmy Song has spun up Istio Weekly's Chinese broadcast called Istio Big Talk to a sizable initial audience. He regularly gets 300 to 500 participants on his Bilibili live stream. And last week's episode on making Istio more efficient is available there, and details in the show notes below. As far as events, if you want to see more of TSB in action, you can join Adam Zwicky live with joint presenters from Keyfactor next week on June 17th for a discussion on zero trust architecture for multi-cloud service mesh. Also, please join us here on Thursday, June 24th, for the next edition of Istio Weekly, where we'll be focusing on security in Istio. And finally, we want to hear from you. What else is happening in the service mesh world? What topics would you like us to cover here? Please leave your thoughts in the comments to this video and on GitHub. As always, links for all of these resources and more can be found in the description below. With that, I'll turn the mic over to Peter.
Awesome. Thanks, Orion. I'm still thinking what Varun's computer was. Mine was Commodore 64. What was yours?
VIC-20.
Oh, okay. All right. Well, I guess we dated ourselves a little bit here, right? All right. So before we actually talk about deploying multiple ingress gateways, which is the topic of today's talk, we have to look at the Istio operator first. So Istio operator can help you manage your Istio installations. So instead of manually installing, upgrading, and uninstalling Istio with YAML, you can just use the Istio operator. Additionally, if you're using the operator, you don't have to manage different Istio CLI versions. Instead, you just update the operator custom resource, and then the controller will apply the changes for you. The operator pattern is a way to automate repeatable tasks. In Kubernetes, an operator uses custom resources and a controller to manage the applications and their components. In case of Istio, we have a custom resource that's called Istio operator and a controller that's deployed in the Istio operator namespace. So let's look at an example. We're starting with an empty Kubernetes cluster, and the first thing we need to do is to deploy this operator. This means just installing the Istio operator controller. So running the istio.ctl operator init command will do just that. It will create the custom resource definition for the operator controller deployment, the service to access the operator metrics, necessary Istio operator RBAC rules, and the namespaces the operator is supposed to watch. For configuration, we can configure in namespace where we want the operator installed to. By default, this namespace is called Istio operator, and we can also define and configure which namespaces the operator watches. So what I mean by watches is next thing that we'll do is we'll deploy the Istio operator resource. However, we have to tell the controller in which namespaces that Istio operator resources will be deployed into, so the operator can watch and then react on those changes. So as I said, once this operator is installed, that it's running, we need to create the custom resource. This is the Istio operator resource. And this resource is just telling the controller how we want Istio installed in our cluster. So here's an example of the Istio operator resource. Now we'll go into the different sections a bit later, but this is the resource we can use to configure, for example, which Istio profile you want to use, the Docker images you want to use, configure any global mesh settings, and then also configure settings for individual components. Like in this example, we are changing the memory resource requests for the pilot specifically. So once we have this Istio operator resource created, then we can deploy the resource to the Kubernetes cluster into one of the namespaces that the Istio operator controller watches. By default, the controller will watch the Istio system namespace. So this is where you would deploy your resource if you haven't customized your operator controller when you initialized it. However, if you configured any additional or different namespaces to watch, the controller will pick up changes in those namespaces as well. So when the controller sees the new resource, what it'll do is it'll take that resource and it will begin the process of installing Istio. So the controller takes the resource and then figures out what it needs to install. So it will install Istio-D, it will install ingress and egress resource, and anything else based on the configuration that we provided in the Istio operator resource. Usually, it takes at most 90 seconds for the controller to pick up the changes from the resource. So from the time you deploy your Istio operator resource to the time that operator actually picks up that change, it's at most 90 seconds. And then after that, it's about 2 minutes. Again, it depends on the configuration that you used, but about 2 minutes to completely install Istio. And this is comparable to the time it would take you to type Istio-ctl and actually wait for the installation to complete. You can monitor the progress. The way you do that is you can just list the Istio operator resource, and I'll show that later in the demo, and you'll see that it will show you the status of the installation. Additionally, since there's an actual pod, Istio operator controller pod that's running, you can also look at the logs to get more details, and this is extremely useful in case your configuration is invalid or if something goes wrong with the installation. So this shouldn't really be a surprise here, but you can control every aspect of your Istio installation through the operator. For example, do you want to switch the installation from, let's say, the demo profile to the default profile? Of course, you can do that. Just update the profile field in the Istio operator and apply the resource. The controller will then do the job for you. Or in this example on the slide, let's say we want to get rid of the egress gateway. What we would do is we would make the change to the Istio operator resource. So we would go under the components, egress gateways, and we would set the field called enabled to false, and then just redeploy that resource. Then the same process will be repeated as with the initial installation. So the controller will notice the change in that particular Istio operator resource. It'll take it, and then it'll make sure to update the installation based on the configuration. In this case, that would be removing the egress gateway. So let's talk a little bit more about some specific things that you can configure in the operator resource. So I've broken it down into three bigger chunks: the so-called global section, the mesh configuration section, and then the components configuration sections, where we can configure individual components of the mesh. Now, one very useful way to discover how different Istio profiles are configured is by just running the profile dump command. So if you run istioctl profile dump and then the name of the profile, you will actually get the YAML representation of the demo profile. So this will help you to, like, you can see all the different settings that are set for the specific profile, all the different components that are either enabled or disabled. It's just one way to actually dig into an example of an installation YAML. Also at the bottom, there's a link to the actual reference documentation where each one of the fields is described in way more details. All right, so let's go to the global section. So this one, I'm calling it global because it's the topmost. Maybe I should call it the topmost section, but I went with global. Someone disagrees, disagree in the comments, and I can say it was Orion's fault, not my fault. Just blame it on someone else, right?
You can always blame me.
Of course. Thank you very much. Now I know. So the so-called global section, or topmost, includes all the topmost fields in the resource, and it allows you to configure things such as the profile name that you want to use for the installation, the path for the installation package, root Docker image path, Docker image tags, namespace to install the control plane resources into, revisions, and there's a bunch of others. For example, the Istio operator in this slide on the right side uses the minimal profile. It has a custom Docker registry set, and a revision is set to custom -010. So this is just an example of how these top level or global configurations could be set on the Istio operator resource. The second section, I'm calling it the mesh config. And this section contains the internal configuration of the control plane components. For example, here's where you could configure the access log format, access log encoding, and any mesh-wide proxy configuration, trust domains, certificates, outbound traffic policy, discovery selectors, which is, by the way, a new feature in 1.10. I think we did a video on it, so we'll share it in the comments. You can set the inbound and outbound clusters, statistics prefix, trust domain, and a bunch of other stuff, right? But this is all the mesh-wide configuration. And by the way, all these sections can be combined. I just have them listed separate here because we're limited on space. Finally, the component configuration. This section allows us to adjust Kubernetes resource settings. It allows us to enable or disable individual components, and then to configure component-specific settings. So the components that you can configure are pilot, you can configure container network interface, CNI, ingress and egress gateways, Istio remote, and then each one of these components also has a Kubernetes field, and that one allows you to configure Kubernetes resource settings. So when pilot gets deployed, that's actually a Kubernetes deployment that gets created. So you can control those settings for that specific deployment. So you could set things like resource requests and limits. You can set annotations. You could set environment variables in the Kubernetes deployment, readiness probes, replica counts, pretty much everything that you could set in a vanilla Kubernetes resource. Additionally, through overlays, you can also provide a list of patches that you want to apply to specific resource. The example in the slides shows you how to modify the memory request for the pilot component. And additionally, on line 16, we're also disabling an ingress gateway that's called Istio-ingress gateway, which is the default ingress gateway. All right, so let's get to the main topic of multiple ingress gateways. Now, the question that usually comes up is, do I need a single gateway or do I need multiple gateways? And then right after that, are all these gateways, should they be publicly accessible, or should they only be accessible internally, and so on? Now, the answer for this one, and I know people are probably not going to like this, but it all depends on your scenarios, of course, right? You have the ability to do pretty much whatever you want. Everything is configurable, so it all depends on the scenarios that you want to cover. So here are a couple of examples just to give you an idea for when you would run and have multiple gateways. So the first one is where you actually want to separate your external traffic. So separate external traffic coming into your cluster from any internal traffic that's coming to your cluster. So you could deploy one gateway that will be used for all external, all public traffic, and then also have an internal only gateway that will be accessible within the same network as your other workloads, for example. The second example can be compliance. So this is where you would want to isolate your gateways in order to make the auditing process easier. Having the infrastructure and having these instances separated makes that much easier. Next one is then having dedicated gateways. This could be either public or internal, depending on your environment. So you might run, let's say, an internal gateway for your development or test environments, and then have a public gateway for your production and or staging environments. Now, using these multiple gateways offers you more flexibility. And then depending on your scenario, you can decide if you need 1, 2, 3, 5, or 10 gateways, and if these need to be external or internal. But again, it depends on your use cases. Now, another scenario, once we're talking about Istio in the context of Istio, the scenario that involves multiple gateways is in multi-cluster deployments. So this is where you're running Istio across multiple clusters. And I'll just briefly touch on this one. As multi-cluster scenarios, this can be like a episode on its own that we'll probably do in the future at some point. So when you're thinking about multi-cluster deployments, there's a lot of questions that you need to ask yourself and actually come up with the answers as well. First one is, are you running the clusters in the same network or across different networks? So single network is the simplest case where all your workloads can communicate directly without an Istio gateway. On the other hand, the multi-network scenario is where you would use one or more gateways, so the workloads from those clusters would communicate through those gateways instead of going directly. Then you need to decide, do you want a single or multiple control planes? This is where you can have a primary cluster and you can have one or more remote clusters. Finally, do you want a single or do you want a multiple mesh? As simple as being is, of course, the single mesh deployment, where service names are unique and all the workloads share a common identity, versus the multiple mesh scenario where you need to federate the meshes to enable the inter-mesh communication. Now, as I said, we'll probably cover these multiple cluster deployments in one of the future episodes. Leave a comment if you would like that. But suffice to say that there's a lot of combinations involved here when you're considering doing multi-cluster scenarios. When there's a lot of combination and a lot of configuration and settings, you can imagine that things can go wrong really quickly. So you'll probably hit a point where Istio won't be enough anymore, and you would benefit from a product that manages and handles operating multi-clusters for you. All right, so let's get back, sorry for the sidetrack, but let's get back to a demo for this simple scenario. So let's say we want to separate internal and external traffic. For that, we will deploy multiple gateways. One will be publicly accessible, and the other one will be an internal only ingress that will be accessible from within the internal network. Now, for the demo purposes, I've created a VM in the same network as my cluster, and that will allow us to access the workloads in the cluster through the internal only ingress gateway. All right, so let me switch to a different screen and we'll do a demo. And of course, this is what always happens when you're doing live demos. My Google Chrome, my Cloud Shell is reloading. I think.
Should I start tap dancing?
Yeah, that's another episode we can do. But yeah, I think my Cloud Shell is actually up and running now, so it should be good. All right, so let's see how we can configure multiple ingress gateways. So I have a new cluster, clean cluster. Of course, I have to do this as well. I just hope my Istio CTL is not messed up, but let's just check that. Yeah, for some reason, and I had to do multiple times this thing. So let's do live debugging here. So we'll do sudo Istio 110 bin, whoops, bin Istio CTL, and I just want to move it. The problem is that whenever like Cloud Shell restarts, stuff is lost. So it just reverts back to the old, oh, I actually need to copy it, right? It reverts to the old CLI. But anyway, CTL, let's just double check that I have 110. Perfect, I do. Okay, and then let's just look at the cluster. Yes, I have a day-old cluster, and I've also created a VM instance separately that's already created. Fingers crossed that it's still there. And we'll use that to show how to access an internal only ingress gateway within the same network. Okay, so to get started, the first thing that we need to do is operator init. We need to initialize the operator. So I just want to show you some of the options here that I mentioned. So the one that I mentioned are the operator namespace. So this is the namespace where your operator controller will be installed into. Default is Istio operator. You can set the revision for the operator tag and then the watched namespaces. So these are the namespaces the operator controller will watch. And you can separate them by comma. By default, it's Istio system. All right, so let's initialize this. So I'm running Istio CTL operator init, and this will create the operator in the Istio operator namespace, as well as all the namespaces the operator watches. Now, since we haven't provided any extra namespaces to watch, it'll default to Istio system. So if I look at the namespaces, you'll notice that I do have Istio system namespace that was created by the operator. So we can also list what was created in the Istio operator namespace, and you'll see there's this single pod, and we can look at the logs, and we'll see that it just started, right? It started, and it's waiting for any Istio operator resource to be deployed. So let's do that. So I will create an Istio operator resource to create an Istio installation. I'll call it default installation that uses the default profile. And this is all that I need to do. We're not configuring anything specifically here. So let's do that. So this created the resource. And if we want to look at the status of the installation, we can list the Istio operator resource. And you'll notice that this is the one that we've created. It's in the Istio system, and it's reconciling at this moment. Once this is, once Istio is installed, once the controller installs it, this will say healthy. Also, by the way, if you're lazy like I am and you don't want to type Istio operator, you can just do IOP, and it works the exact same way. So this was a good time filler because by this time Istio was installed. So it was all good. Istio is installed. So let's look at the namespace, the Istio system namespace. We have the Istio-D and we have the Istio ingress gateway, which is all part of the default Istio installation profile. All right, so next thing that I'll do is I'll create a namespace called internal, and then we will create a second operator that will install an internal gateway to that namespace. So let me paste in the resource, and then we'll talk through it. So again, creating it in Istio system. We're calling it internal gateway. Could be whatever you want. The profile is empty. So the empty profile means don't install anything. I want to customize everything that I want to install. And then under the components and ingress gateways, we're defining the namespace where we want this gateway to be created. We're enabling it, right, by setting this to true. Also setting the label. Otherwise, it will get the exact same label as the default ingress gateway in Istio system namespace. And then additionally, I'm setting the service annotations here. And this is specific to Google Cloud. So if you're on AWS or anywhere else, these annotations might be different. And this is just telling Google Cloud, hey, I want this to be an internal load balancer. Let's do this. So now we've created a second resource, Istio operator. So let's list that one. This is the original one, which is healthy. And then the second one is still reconciling. And it means it's just creating the ingress gateway. And now it's healthy. So if we look at the pods in the internal namespace, you'll notice that we have this internal load balancer gateway. Let me also show the labels. So the label that we've changed was Istio, this one, Istio internal ingress gateway, right? But you can, of course, add your own labels or modify the existing ones as well. Okay, so in order to be able to access the workloads that are running inside the cluster through the gateway, we need, of course, the gateway resource. We're creating it in the internal namespace, calling it internal gateway, and then using the selector for that gateway that's running in this internal namespace, so the internal load balancer. Okay. Also, I'll just deploy HTTP bin. Before I do that, I just labeled the internal namespace for injection, so we actually get the proxies injected. And then next thing that I'll run is I will just deploy the HTTP bin sample into the internal namespace. So let's list this one. So we have the HTTP bin workload running with the proxy injected, and we have our internal gateway running as well. And then the last thing that we need to do is we need to create a virtual service. And in this virtual service, what we're doing is we are attaching this internal gateway to it, which basically just means we want to expose this specific service through the internal gateway for all the hosts. So let's do this. Also, let me just list the services, and I'll do internal, right? So services from the internal namespace. You'll notice that this is our internal load balancer gateway service that we've created. It is a load balancer type, but notice the external IP is not really an external. It's the same as the cluster IP and the same address space pretty much. So if I would try and curl to this one, this is not going to work. This will time out because it's an internal only IP. So for that reason, I created a VM, a very clever name of instance 1. And then from this VM, I could actually go and curl to, if I can find the IP address, just copy the internal IP address. So if I would curl to this guy, and I need to reconnect, and then we'll say, I think headers, right? There you go. You'll notice that I get back the response. And this is me from the VM that's inside the same network as my Kubernetes cluster. I can actually make a request to that gateway on the header spat, and then I'm getting the response back. And you'll see that this is actually coming through the Istio ingress gateway. It's using the Envoy, right? And of course, let me open Google Cloud Console. Let's just show this one as well. If I do load balancing here. you will notice that I have an internal load balancer that was automatically created for me. And this one is actually pointing to that ingress gateway that we've created in the internal namespace. All right, let me switch to back to slides. I only have one more slide. Let's do this one. Share. All right. Okay. All right. So what I wanted to share after this demo is just a couple of tips tips to keep in mind and things to keep in mind when or if you decide to deploy multiple gateways. Now, note that this is not necessarily just for the gateways. It could apply in other situations as well. The first one is to use a separate Istio operator resource with an empty profile. So what this will allow you to do is it will allow you to keep your operator for your base Istio installation configuration separate from any other add-ons or modifications you might make later. And it also makes it easier to manage and read the configuration files like that versus having a one large file with all the settings in there. Second, don't forget to set the different labels for your second ingress gateway, because you don't want to have two gateways with the same labels. You don't want that. So make sure you either update the existing labels to something else or set your own labels and then use those when you're creating the gateway resource. Next, if you're deploying an internal only ingress gateway, set the appropriate annotations as well. And this will depend on your cloud, on the cloud vendor that you're using. It depends on where you're running your cluster. Finally, if you don't want to use the same, let's say, resource limits and or requests for, in our case, for the gateway, make sure to adjust those as well, either up or down. All right, so this was all for me. I'll hand it off back to Orion.
Thanks, Peter. And thanks for putting this together. It's super helpful. I'm going to go try it out, of course. We hope you all found it useful. And we also hope you'll join us in 2 weeks on the 24th for our next episode, where we'll talk about security in Istio, which is what I said at the top. So I'm saying it again, because repetition is the key to humor. You can find the Istio weekly schedule and all about Istio, or Tetrate, Istio distro, and community at istio.tetratedlabs.io. We've put all the tutorials material from this presentation up on GitHub at github.io/tetratedlabs.io/Istio weekly. Links to that on istio.tetrate.io/community. Chat with us on the Get Istio channel in the Istio Slack workspace, slack.istio.io, or leave a comment on this video. We look forward to seeing you next time when we cover, another repetition, security in Istio.
Yes, that security will be a good one. Also, if you don't want to go to the GitHub IO and remember all those URLs, you can always go to istioweekly.com. And from there, you'll find all the links to pretty much everything that we told you in this stream, and all the links that we mentioned as well. All good?
Sounds great.
Awesome.
See you next. Same bat time, same bat channel.
Yes. Talk to you then. Bye.